This video will be a quick start guide to creating, running, and analyzing the results of a simple river basin simulation model in Basin. After installing Basin 7, execute the program, and the first screen that will pop up is the Basin title screen. To create a new basin, we select the Add Basin button on the screen and type in a name for our river basin model. For this case, I will call it Virgin. Take note that in Basin, you can only specify a maximum of 8 characters for your river basin name. Once you have typed this in, click OK. It will ask you if you want to continue to work with this basin, and click Yes. And the case management tool will appear. On the main screen of the case management tool, you will see a flowchart which will guide you through the different tasks of setting up, running, and analyzing your simulation. We must first initialize our case by going to the top left corner of the screen, selecting Case, and selecting the New option. You will see the different task blocks light up with different colors, indicating the different status of these tasks. A red color means that you cannot start this task until you have completed a preceding task. Yellow means that you can start this task. Green will eventually mean that your task is completed, and purple will mean that your task is running. The first task that we can access is to select Scenarios, Measures, and Strategies. We can double-click on this block, and a combo box will appear for selecting different scenarios that you want to simulate. For the hydrological scenario, we will use a ready scenario 1-to-1, and for the climate change, land use, agriculture, and basic water quality and management actions, we will keep it simple and ignore these scenarios. So selecting scenario 0-0-0. These scenarios are created outside of Basin, and there is a separate tutorial in how to create these scenarios in the next videos. For now, let's click OK. And you can continue on to specifying the simulation control data. Double-click on this block. And the main action here is to specify our simulation period. We will keep this now at default and also ignore any water quality computation. So we will simply click OK. The next step is to create your network. Double-click on this block. Select the Edit Network and Object Data button. And this will open the interactive network editor that we call Netter. We will create a simple model with one main river channel and one tributary attached to this river channel. To create your network, select the Edit Network button at the top of the screen, which will give you access to the node and link toolbars. First, we must add our inflow nodes for our main river channel and our tributary. To do so, we select the Add Node button. Make sure that the variable inflow node type is selected, and click on 2 locations on the screen once. We must also specify the confluence of our main river channel and tributary. This will be done by adding a confluence node by clicking once on the map. Furthermore, we must specify the end of our model by selecting the terminal node and again clicking once on the map. The next step is to connect our different nodes, and under the connection toolbar we can select the Connect Nodes button and make sure that we have the surface water flow link type selected because it is a river and a tributary. And selecting with our left mouse button one of the variable inflow nodes, we can drag across to the confluence node. Do the same for the tributary. And then finally connect your confluence node to your end point. You can also rename your nodes and your links by clicking on the Rename button and left-clicking on one of the nodes. This top right node will be my main river channel. I will call Main. Top left will be my minor river channel. I will rename also the confluence and the endpoint. I will do the same for the links by also left-clicking on a link location. This top right will be my main river channel 1. top left will be my minor 1. And between the confluence and the end, I will also call it main 2, as it is still my main river channel. You can display the names of your nodes and links on the map by going to the Options toolbar, selecting Options, and under the Node folder, selecting Name. Do the same for the link, Apply, and click OK. After creating our network, we can then enter the property data of our nodes and links. The required data depends on the node and link types, and you can refer to the user manual on attachments 6 and 7 for this information. For our simple river basin model, we only have to enter the inflow in our variable inflow nodes. To do so, first exit the Edit Network mode, selecting one of the inflow nodes with your left mouse button, then right-click on the same location to access the model data of your river basin simulation model. This will pop up your data editor sheet, and on the first folder, it shows the different characteristics of your nodes, and on the second, you can specify the variable inflow. To do so, you can assign the actual inflow time series index 1 and 2. These indices refer to the time series in your hydrological scenario. Another video will explain the hydrological scenario in more detail, but for now we'll keep it simple and stick to these numbers. Finally, click Apply and OK. Once our network is created and the data attached, we can save our network under the File tab in the toolbar, Save Network, and then exit Netter. Under the same task, we can generate an overview in table form of all the node and link property data used in the simulation. To do so, click on the Generate Overview of Database button. Once this is completed, select View Tables of Database and open the report. Here you will find information on your model, the time series that you've read in, as well as the simulation period. Now exit this log. And finally, once this is green, we can run our river basin simulation. After your simulation is completed, the task block will turn green. If in your case this run fails, you can right-click on this block and select Log Generate DLF file. And this will list possible errors detected on the previous steps as well. The final task is to analyze the simulation results. Double-click on this block. And it will give you 3 format options for viewing your results. If we select On Map first, it will bring up Netter again, showing the layout of your model. The thickness of the lines represent the magnitude of the link flows for each link. And you can navigate to different time steps by clicking on the scroll menu on this window to the left. You can select one of the links and clicking on the graph icon, it will present you with a time series of the inflow or the flow through this link. To edit the graph, double-click on this screen, and it will give you options to also, for example, change the graph type from line to a bar graph, for example. You may also display 2 links in one graph by, on your keyboard, holding Control and selecting another link, and again, clicking on the Show Graph button. This will display the 2 links on one graph together. On the top left, you can choose to export this image to different formats. And you may also choose to copy the data to clipboard so you can paste this in Excel. Exiting Map View, we can view the results on charts as well. For now, to keep it consistent, let us look at the link results. Click on View Export, We select link flows. You can select locations individually, but for now, let's select all. Similarly, you can select time steps individually, but for now, we can select all. Click on graph at the bottom left, and it will give you a graph of the data that you have selected in the previous screen. Here, you may also export and copy the data to clipboard. Exiting this screen, we can also generate a report of our results. This is particularly handy for getting the water balance. If we select the overall river water balance option and click on view, we can see the amount of water that flows in to our system through our variable inflow nodes and the water that flows out through our terminal node, reflecting the water balance of our system. If we exit this report, all our tasks are now green. Now, so far we have only been working in a working environment and none of our runs and parameters are saved in the River Basin folder. To do so, we can select Case, Save As, and we refer to this as the base case. Select OK, and you will also notice that the name of your case will pop up at the top of the screen. We will use this base case to add scenarios in the next videos, but I hope this was useful as the first step to creating and running and analyzing your simulation. Thank you for your attention.